Hi class, in this video here I want to give you an introduction to section 5.1. It's called rubber sheet geometry. And what this is talking about is discovering the topological idea of equivalence by distortion. All right, so what's going on in this section? We're going to start talking about rubber geometry. So fooling around with like rubber bands, it can be fun, but besides its entertainment value, it can stretch the imagination. All right, to introduce the idea of what we call elastic space, the text presents three short tales. Okay, and I thought this joke was good. Well, since they are rubber stories, they can be stretched into tall tales. But okay, so what I want to do in my lecture here is I'll explain the first short story to you, and then you'll have to read the other two. And the other two are important to read because they are the foundations for some of the later stuff we learned. So in my future lectures in this chapter, I'll assume you have read the other two stories. Okay, so here's the first one. All right. And let me set it up with a little bit the technical name of all this. So this rubber geometry was evolved into a branch of mathematics known as topology. The word topology was coined in 1847 and derived from the Greek word topos, which means surface. So topology is a mind-stressing subject that frees us from conventional geometry and allows us to appreciate geometric characteristics of objects that remain unchanged even when the objects are stretched, shrunk, distorted, or contorted. So like, for example, if you think of a rubber band all the way here on the left, you can distort it and stretch it so that it's the same as a square here, or you can make it into a triangle, or you can make it into a circle. So, through distortion, we can take this rubber band and have it be equivalent to each of these by distortion. All right, and so here's the first challenge we talk about, okay? One of the authors frequently wore a natty suit complete with a vest. You can see here we have this vest, okay? One day he read in Vogue that vests are considered old-fashioned, even stodgy in some circles. He studied the article carefully and noted that the suit jacket was definitely on the way out. Not wishing to be out of fashion for even a moment, the author, he wanted to immediately remove his vest without removing his jacket. After investing some thought into the puzzle, he wondered if he could accomplish this vest removal without unbuttoning either the vest or the jacket. And the only way you can do this, obviously, is if the vest were made of an extremely flexible, stretchable rubber-like material, like a rubber band. And this is what we're going to talk about with rubber geometry. Okay, so how could this be done? So his vest here, you can stretch it and contort it any way you want. Okay, but what you cannot do is you can not take it off or unbutton your jacket. So can this be done? Well, yes, it can. All right. So to illustrate the notion of topology, we first turn to the divestment challenge. That's what this is called. And examine how, if the vest is made of very distortable rubber, we can remove the vest without even unbuttoning the jacket or the vest itself. Okay, so because the author, he's not allowed to unbutton the vest has the same characteristics as a pullover sweater vest made of rubber. Okay, so something like this. So the same characteristics as this. As the vest is extremely flexible, it can be shrunk. You can shrink the bottom part of the vest upward without changing the topology. So basically, you're just shrinking it. You're just rolling it up. Okay. So in fact, if you can shrink the bottom of the vest so that the bottom seams comes within an inch of the head hole, like right here, okay, and the armhole, so it's really, really close, the vest now appears to be more like a stretchable tank top. So something like this. Okay. Notice that all the shrinking can take place without the vest ever leaving the cozy confines of the jacket, right? You're just straight, shrinking it up. You haven't unbuttoned anything. Okay, so underneath, you've just turned it by just shrinking it up, rolling it up a little. You've turned it into this. Okay. He can now stretch one shoulder strap down through the original jacket sleeve to his hand. Okay, he can press the strap around the hand. So basically, what he's doing is he's taking this sleeve that we have right here, and he's going, pulling it down. And then when he gets down, the top part, he's going to wrap around his hand and pull it back up. Okay. If he then moves the other shoulder strap down and does the same thing, okay. All right. We see that the straps are no longer over his shoulders. And thus by wiggling, he can now slide this underneath his vest and down his pants. Okay. He can then pick the tank top back up that he stretched and stretch it to the original vest. And so that's how you can do it. And then what you're going to learn in this section here is you can stretch and wiggle and pull things out like this so that you can do some really interesting, fun stuff like take the vest off without ever unbuttoning the jacket. And actually, in one of your assignments this week, you'll be asked to explain how, like, if you and your friend each have ropes tied around your hands, how you could, undo the ropes without, untying or untangle yourself from each other without untying the ropes. All right, so please read the other two stories in this section as they're important for future analysis. And as always, if you have any questions, let me know.